Welcome to Real Civil YouTube channel. In this video, we are going to see how to find the reaction. Okay, theory we have covered in the last lecture, so you can watch that video in the description box. The link is there, or you can simply click on the I button. Okay, so let's see how to solve this problem. Generally we have to find out the reaction while solving the beam. So first we need to draw the free body diagram of the support. Okay, here it is a fixed support and at other end there is no support. So we know that whenever there is a fixed support, we have covered this part in our theory part. So we know that whenever there is a fixed support, then there will be one vertical reaction, one horizontal reaction, and one movement will be there. These three forces or these three things will act when there is a fixed support. Okay, that is the first thing. Now, second thing while solving such a problems is to see how many types of loads or how many loads are acting on the beam. Okay, first here you can see it is the UDL. Okay, types of load. So first one is the UDL, that is uniformly distributed load. Then second is the inclined force or load, you can say. And third one is the concentrated vertical load. Right, here you can say inclined concentrated load also. No problem. Okay, so what we need to do here is to draw the free body diagram. Okay, so let's start. So first draw this 3 meter length of the beam. Okay, so this is 2 meter, this is 1 meter. Okay, now we have to show the loads, but here we will draw the free body diagrams. Now if you see the carefully, here there is a fixed support. So for fixed support there are three reactions or three things. First is the vertical support VA, horizontal is HA, and there will be one movement called MA. Direction you can assume upward, downward. For horizontal, right side, left side, you can assume anything, no problem. Okay, now we have shown the free body diagram of the support. Now there is a UDL. For UDL, what we have to do, first thing I will show here, you have UDL. Okay, so first write the intensity of UDL. Okay, and then you have to multiply on length over which UDL is acting. Okay, so if you see this figure, the intensity of the UDL is 10 kilonewton per meter. So just write here 10. Now into what I have written here, length over which UDL is acting, means the length over which UDL is acting. Here clearly you can see over 2 meter span the load is acting. So just multiply here by 2. So you will get a 20 kilonewton load. Now where to show this load? Show at the center of length over which UDL is acting. Means what? You have to show this 20 kilonewton force, okay, at the center. this is 2 meter, then at the center you have to show this 20 kilonewton. So I am drawing here a separate free body diagram where I have shown the fixed support. Now this is 2 meter over which UDL is acting. So at this point, let's assume this point is at 1 meter. You have to show one point load of 20 kilonewton. That 20 kilonewton, this is the way we have calculated. Okay, next thing is here an inclined force at a distance of 2 meter, means this is the 2 meter here, and this force is, this load is like this. Okay, so just here show like this plus sign, and this is the downward direction, right? So like this. So you have to resolve the forces in these two directions. Okay, so this is the force, so we will resolve here. Okay, we know the resolution because here the angle given is 60 degree. Okay, so this will become 20 sine 60 and this will become 20 cos 60. Okay, as we know this is 20, after resolution this will become 20 cos 60, this will become 20 sine 60. Okay, and at the end here 15 kilonewton point load is here, so there is no need to change. Okay, so this is our free body diagram. Now you can solve this problem very easily. Okay, so first we will do summation Fy is equal to 0. Okay, so summation Fy is equal to 0. In that, what we will do, we will do the summation of the forces having this direction. If it is upward, we will consider positive. If it is downward, we will consider the negative. Let's start from the left hand side. Okay, only vertical. For Fy, only vertical. Okay, so this is Va, upward, hence positive. Then this is 20, which is downward, negative. When you resolve the force, forget this inclined force, only concentrate on the resolution. So this will become minus 20 sine 60, right? Then this again minus 15, which will be equal to 0. So our Va will become 20 plus 20 sine 60 plus 15. So our Va will become equal to 52.32 kilonewton. So this is our first answer. Okay, Va. Similarly, we have to calculate Ha. Now just look carefully. Ha is horizontal. Okay, so we have to do summation Fx is equal to 0. In summation Fx, we have to consider all the horizontal forces or loads. Okay, in that, if it is in the direction right side, consider positive. If it is left side, consider negative. Now start from the left hand side. Here horizontal force is Ha, which is in the right direction. So we will write here Ha. Then the horizontal force is this 20 cos 60, which is in the left hand side direction. So this will become minus 20 cos 60. Let's see if any other horizontal force is there. No, any other horizontal force is there. So equal to 0. Hence Ha will be equal to 20 cos 60. So Ha will be equal to 10 kilonewton. So this is our second answer. Now only remaining thing is MA. We find out the VA, which is equal to 52.33. We have find out HA equal to 10 kilonewton. Only MA is remaining. So let's find out the MA. For that, take moment at point A. Okay, and the rule is if any force is passing through the point A, then its moment will become 0. So we don't have to consider that force. Okay, we are taking the moment at A. So VA is passing through A, HA is passing through A. We don't need to consider, but here an external movement is acting. So sign convention is clockwise positive, anti-clockwise negative. Okay, clockwise means in this direction, anti-clockwise means in this direction. So MA is clockwise, hence positive. Now next is 20 kilonewton force. So movement is force into perpendicular distance. So this 20 into 1. So its direction is anti-clockwise. Okay. So minus, so first is plus MA minus 20 into 1. Then here see the resolution only, forget this force because we have resolved it. So this force will again pass through point A, no need to consider. Now consider this force. So the distance of this force from point A is 2 meter. So 20 sine 60 into 2, and which is minus because it is in the anti-clockwise direction. Sorry, it is in the clockwise direction. 20 is also clockwise direction. So you can consider this as a positive and this as a negative. Okay, only sign is different. So 20 sine 60 into 2. So 20 sine 60 into 2. Now next force is 50 kilonewton, which is again clockwise. So 50 kilonewton into the distance from the point A, which is 2 plus 1. This total distance is 3. Hence 50 into 3. Here we will consider 50 into 3. Okay. So this force is anti-clockwise. Hence minus. All these forces are clockwise. Hence positive. So equal to 0. Hence MA is equal to, so you have to put all the things here, 20 into 1 plus 20 sine 60 into 2 plus 50 into 3. After solving this, you will get the MA value equal to 99.64 kilonewton meter. Okay, so this is the way you have to solve the problem. Sign convention is if it is, you can show like this. If it is clockwise, consider positive. If it is anti-clockwise, if it is like this, consider negative. Okay, so sign convention you can consider anyway, your answer will get correct. We'll solve again another one problem. So this is our first problem. We will solve the another problem where we will see the problem related to uniformly varying load. Okay, so thank you so much for watching the video. Please like, share, subscribe the channel.